So welcome everyone. Today we are going to make a model of 23-story building, and first of all let me show you the plan of what we are going to make. So this is our plan. First we will draw a story 1 to 8 that will be of dead load 2 kN, live load 5 kN. Then the next is story 9 to 14, dead load 2 kN, live load 4.5 kN per meter square. Then we have story 15 to 19, dead load 2 kN per meter square, live load 4 kN per meter square. And then at last we have story 22, 23, dead load 2 kN and live load 3.5 kN. We have the following beam and column section which we will be using the auto select method. Column 500 by 500 millimeters, 550 by 550 millimeters, 600 by 600 millimeters. Similarly, we have beams for 500 into 300 millimeters, 550 by 350 millimeters, 600 by 400 millimeters. We will be using M40 concrete, HYSD 500 mild 250 rebar. The slab thickness will be 150 mm thick and the concrete will be grade M40. We will be using auto draw cladding option, and cladding load that will be applied is 0.2 kN per meter. For the wind parameters, we will be considering the city Bangalore, that our building is situated in Bangalore. So now we will be opening ETABS softwares. Okay, so now we have ETABS opened. So after opening ETABS, we will go to the file menu. In the file menu, we will go to the new model option, and in new model option, as you will be see that already the Indian database codes for steel and concrete have been set, so we don't need to change them. Okay, so here we will be using use built-in settings with. In use built-in settings, we have already selected design unit metric SI in steel session database Indian, steel design code IS 800, concrete design code IS 456. Now we click OK. It will ask me about the quick template. Then here we are going to enter the number of grid lines in X direction, as we have seen 4, number of grid lines in Y direction again 4, spacing of grid in X direction is 6 meter, spacing of grid in Y direction is again 6 meter. Now number of stories we will move here, it is 23. Typical story height and bottom story height, both are we going to keep as 3 meter. Now custom story data and edit story data. In custom story data, we have to divide our building into 4 parts, 4 similar parts. From story 1 to 8 we have a similar story, so we will change the master story for story 8. We can change for any one of these, but we are going to change it for here for story 8. Yes, and similar to this for story 1 to 7 we are going to put it as story 8. Story 8. Story 8. Now we will move to next. After story 1 to 8, next we have story number 9 to 14. From story 9 to 14, again we will go to story number 14 and select master story as yes, and story 13 we will select similar to story 14. Similarly this one and others also. Now since we have done this one also, we will move further up, story number 15 to story number 19. For story number 19 we will change it first to master story yes. Now story number 18, this will be similar to story number 19, story number 17 similar to 19, and so on. Now rest of the story for story 21, 22 and 20, it will be similar to story number 23. Now we have done this part. Now we click OK, and then we will go to grid only option and click OK. This will generate our grid lines. Okay, so now we will go to define materials. We will go to define option menu. Define menu, we have material properties. We will add new material. Region is India. Material type is concrete. Standard is Indian, and grade is M40. Click OK. So these are the default settings and we don't need to change anything here. We will simply click OK. M40 is now added. Now similarly we will add other properties. change this to rebar HYST 500, click OK, and okay. Again we will add new material for mild steel, mild grade 250, okay, and then again okay. So we now have M40, HYST 500 and mild 250, click OK. After defining this, now we will have to define the section. We will go to define menu, section properties, and section properties we have frame. In frame section we will add new material, add new property, concrete. We will change the name as column 500 by 500. Change this M40. We put the depth as 500 and width as 500. Now we will go to the reinforcement option and modify show rebar. Click on. We have column selected since we are designing and entering the section for column, and then we will choose longitudinal bars for HYST 500, confinement bars as mild 250. Now the clear cover we are going to provide is 40, and rest are the default setting, we don't need to change them. Click on OK, and then again click on OK. Now since we have one property, we will go to select this property and add copy of property. This way we will not have to require to enter all the properties, we will only have to enter those properties which are dimension 550 by 550 and 550 550 and click on OK. Again we will select any one of these and add copy of property. Change this to C 600 cross 600. Change this value to 600. Change this value to 600 and click on OK. Now we have the columns. Now we are going to add new property and select auto select list. In auto select list we are going to name the property as auto column. Then I'm going to change the material as concrete and select all these three properties and add. Then we will click on OK, and here we have the auto column. Now the best section that will be suitable for the building will be automatically selected by the software. Now again we will go to add new property, and again we are going to select concrete rectangular. Now we'll change this to beam. Now we are going to define the beam section. So what are the dimensions of the beam? These are 500 by 300, and the material is M40. We'll have to change it here also, 500 depth and 300 width. Modify show rebar and select beam option and change the cover to 25 mm and 25 mm. Then we'll change this to 500 Fe500 and confinement bars to mild 250. Click on OK. Again click on OK. Now we have the section of beam 500 by 300. Now we need two more sections, 550 by 350 and 600 by 400. So we are going to make a copy of these properties, copy of property, and we will do beam 550 by 350, and we are going to change it here 550 by 350, and rest of the properties will be same. Click on and modify show rebar option. These are the dimensions which are already changed since we have done copy of property. Click on OK. Click on OK. Similarly, once again we are going to do this B 600 by 400 and 600 depth and width is 400. We'll click on OK. So now we have defined the beam section. So now we are going to add new property and do the auto select list option. and we will go to property name and enter auto beam. Now now we are going to select, since this is not showing here, we need to change this to concrete, and it will show the beam properties, and we are carefully select the 3 beams and add it here and click on OK. Now we have auto beam and auto column. After defining these things, we will click on OK, and now we will go to define section properties and slab section. In slab section, we will add new property and name the slab as slab 150. We will change the slab material to M40 and then slab thickness to 150 mm and click on OK. We have defined our new material, and then we will click on OK. Now we will be drawing the elements of the building. So first we are going to story 1. In story 1 we will take similar story option and quick column. Now we will change this value to auto column option. Now we can draw the column. We will select all. Now to draw the beams, again we are going to select the beam option and change the property to auto beam and draw the beams. Now we will have to draw the slab section, so we will change this value to slab 150 and similarly we will draw the slab. So now we have drawn the frame structure for story 1 to story 8. Now we will go to story number 9. Now in story 9, again we are going to repeat the process, but we will select the column, and after selecting the column carefully, we have already selected the auto column option, and we will carefully select the column that we want. Okay, so column is done. Now we will draw the beam. Now the beam is drawn. I will draw the slab section. So we have done the slab section. Now we will again move up to story number 15. As per the plan of story number 15, again we will draw the required columns. Go to column, auto column option is selected, and we'll have to draw the columns here. So we have drawn the columns. Now we'll draw the beam. Just the beam. Just the beam. This is our beam, and this is our beam. So now we have drawn the beams. After drawing the beam, we will have to draw the slab section. Now we will repeat this process for story number 20. Again we will go up to story number 20. In story number 20 we have this section and this section from story 20 to 23. So again we will select the quick draw column, and here these columns are required. We have done that. Now we will go to the beam and assign the beams. Now we will select the auto beam is selected. I will go to the slab, and now we have drawn the slab section. So now after drawing the slab section, the next part is applying the loads. So to apply the loads, We'll again go to the base. Now we'll go to story 1, and in story 1 we'll select the all story option. Now we will select one by one, we will select all the shell elements. Now you can see in 3D that only those where there is no shell present, nothing is selected. And now we'll go to the assign menu, uniform, dead load. We'll apply the dead load of 2 kN action gravity. Click on apply and click on OK. Now after applying the dead load, again in story 1 we'll select similar story option. Now we'll have to apply the live load. So for live load we'll select similar story, we'll select the shell elements. After selecting the shell elements, go to assign shell loads, uniform. Now change the load pattern name to live and change the load value to 5 kN per meter square. Now apply and then OK. Now we'll move to story number 9 and again apply the live load. In story number 9 again we have similar story options, so we'll select the cells. After selecting all the cells, go to assign shell loads, uniform. We'll change this value to 4.5 kN per meter square. Load pattern will be same as live. Apply, then OK. Now we'll move up to story number 15. So now in story number 15 we have similar story option. Now this, and then now we'll go to assign shell loads, uniform, and change this value to 4 kN per meter square. Apply, OK. Now we'll go up to story number 20. In story number 20, select this story and this story. Now again go to assign shell loads, uniform, change this value to 3.5 kN per meter square. Replacing and click on apply and click on OK. Now we have done all the dead and live load. So now we are going to apply the load of claddings. The load of claddings is applied only to the external beams. So we will go to the story 1. In story 1, carefully we are going to select the exterior beams using similar story. So select this, 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 and this way we will select all the stories. So after selecting all these stories, we go to assign, go to frame load, distributed, and uniform load. We change this value to 0.2 kN per meter. Click on apply and then OK. Now we'll move up again to story number 9. Again we will select the exterior beams. After selecting these stories, now we'll go to assign frame load, distributed, 0.2 kN per meter square, dead load, apply, OK. Now again I will repeat this process for story 15 to story 19. Now since similar story option is missing, we go to display option, undeformed shape, and you can see similar story is present. After selecting all the exterior beams, go to assign frame load, distributed, 0.2 kN dead load, apply, OK. Now again we will repeat this process for story number 20. You don't need to worry if this similar story option disappears. If you had set it initially, it would be similar story, but to show you that similar story will reappear. Now select this, now assign name load, distributed, 0.2 kN per meter, dead load, apply, OK. Now this is done. Now after applying the dead load, now we will go to the base. In base, we will have to select all the base points and assign joints change to fixed, apply, OK. In cladding there is no load on the top floor, so we will have to remove the load from the top floor. We will go to the story 23 and the top floor does not has any load. We'll select one story here, assign, we'll go to frame loads, distributed, delete existing of, apply, OK. Now after doing this, we go to draw and auto draw cladding option, use floors, click on OK. You can see we have the claddings on all the floors. Now we will be applying the wind load. Wind load will have to be applied to each elevation section of the building separately. So first we will go to the define menu. In define menu we have load patterns. In load patterns we will be writing wind here, type as wind, auto letter load as IS 875 1947 and add new load. So wind load has been added. Now we'll go to the modify lateral loads option. In modify lateral loads, first we will enter the wind speed. So for wind speed we will have to refer the IS 875 part 3. So let me OK. So this is the wind load IS code. We'll go to the, this is the map. So we are in Bangalore, and for Bangalore it is situated in this region. So for this region it is, the value is 33, but you can also see it from the appendix, this, you see Bangalore 33. So we'll go back to the software and enter wind speed to 33. Now we have terrain category. We'll find the terrain category. For terrain category we will refer clause 5.3.2.1 in the IS code. We'll see that Bangalore lies in category 3, terrain with numerously closed space obstruction having the size of building structure up to 10 meter in height, with or without few isolated tall structures. So in category has 3. Structure class, again we'll have to refer the IS code for the structure class. So this is class C, greater than 50 meters. Our building is greater than 50 meters, so the class of building is class C. We'll select structure class as C here. Risk coefficient factors, for risk coefficient factors again we'll have to refer the IS code, table number 1. In table number 1 we are designing our structure for 50 years, so we'll keep it factor value as 1. It is the value. Similarly, the topography factor, we can see the topographic factor in clause 5.3.3.1. this, then below the value of 341. Now click on OK. Now again click on OK. Now select elevation option, go to elevation A and click on OK. So in elevation A we'll go to all stories option. We'll select the story. Now after selecting the shell claddings, we'll go to assign shell loads, wind pressure coefficient. Now wind pressure coefficient we need to assign the coefficient value. So the coefficient value we'll have to look in the IS code again, IS 875. So going back, for our structure we'll refer to this values for A, B, C and D. For A it is 0.8, for B minus 0.25, for C and for D it is minus 0.8 both. So we'll enter 0.8 and windward side and apply, then OK. Now we'll again go to elevation and select D and click on OK. Again we have all stories option. We'll select this shell cladding, go to assign, shell loads, wind pressure coefficient 0.8 and apply. Click on OK. Now we'll go to the elevation, go to the section D, click on apply and click on OK. In section D we have to select this, this and this. Now after selecting this, go to assign, shell loads, wind pressure coefficient and change this value as seen from the IS code to minus 0.25 keyword side and then click on apply. OK. Now again we will repeat this process for section C, elevation. We'll go to the section C and apply and then OK. Then we'll go to this, we'll select this and we'll select this. Go to assign, shell loads, wind pressure coefficient, take this value, go to the elevation, go to section 1 and apply. OK. Section 1, we'll select this, this and then this. Since in all the four is same, so we'll section 2, this, this, let's see, this, this and this. Section D, this, this, this. Assign, keyword, apply. Okay. Now we can go to the plan view and select story 1, click on apply, then click on OK. You can see all the loads have been applied correctly. Now we can move up to story number 9 and we can see that the load is, yes, you can see that the load has been applied. Similarly, we can see that the load has been applied to story number 15. So since all the property section load have been applied to the building model, so we can now run analysis on this building. So before analysis, and we'll go to the use extrude view for frame objects. So we have the extruded value. You can save the file before running analysis. Go to analysis, go to run analysis. Now the analysis is done. We can check the displacement values from here. You can see the displacement of any point. We can also see the shear force and bending moment diagrams. Shear stress forces. We can see this. See the value of forces acting. So now after analysis is done, we can do the designing of our building. We'll go to design option, concrete frame design, view revised preferences, and we'll see the design code is IS 456-2000. Click OK. Now again we will go to design, concrete frame design and start design check. So it is saying that the analysis and design section require for 705 concrete frames. Do you want to reiterate analysis and design? So we will reiterate it. Say yes. Now the software will run design again and auto select the higher dimension of the frame member. It is saying that analysis and design section require for 10 complete frame. Do you want to retrace analysis and design? So again we'll say yes. So now after the designing is complete, now we will go to again design, concrete frame design, and go to verify all members passed. The message will appear that all concrete frame members passed the design check. Click OK. So now since all members have passed the design check, our building design is complete. We can see the project report and summary report in report tab. Project report, summary report. Hence we have completed the design of a tall building and also generated its project report. Thank you.